button on the Go to Webinar control panel to allow all attendees to hear you. This system will notify you once you begin your broadcast. The broadcast is now starting. All attendees are in listen-only mode.
Good evening, everyone. We're going to start today's session. So in today's session, we'll see the continuation from the last week. 1 minute. So we'll see the continuation from the last week. Last week, we were discussing about SQL script. So I was giving you introduction to SQL. So let me log into system. So we'll continue the SQL. So let us log into HANA Studio. So today we are focusing on the SQL script. Okay. Now, so coming to the different joins. When you right click on the content, let us create one package, SQL script. Right click on the package, click new, click on the calculation view. So in the calculation view, here you see there is a subtype, standard and time. The same calculation view you have type as graphical and SQL script. So let us select SQL script. Let us provide a name, SQL joins. So inside a calculation view, there are two. One is graphical calculation view, and the other one is scripted calculation view. So here it's a scripted calculation view. So what are the different types of joins? And what is a join? A join is a clause used to combine rows from two or more tables. So if you want to join two or more tables, we use the join clause. Again, in join, there are different types of joins. One is an inner join. Inner join. The second one is left outer join. So for everything in the SQL, you have the CE functions, which are known as calculation engine functions. For every different type of joins, you have CE functions. So CE functions are known as calculation engine functions. In calculation engine functions, you have function to read tables, you have function to read column views, we have function to read joins. So there are different types of CE functions. Now whenever you're using joins, so these are the examples. So for inner join, we use something called CE underscore join. If you're using left outer join, we use CE underscore left underscore outer underscore. If you're using right outer join, shortly I will explain you what is the use of each join. So for this, the C function is CE underscore. I'll show you with examples on how we can create them using different scripted. Show you the examples on how you can create with different scripted calculation views. For right outer join, you have C underscore right underscore outer underscore, and then you have full outer join. C underscore full underscore, and then you have CE projection. These for projection. You have CE underscore projection. You have calculation. For calculation, you have CE underscore. And then you have CE underscore aggregation. C aggregation, you have C underscore union. underscore all. So this is for aggregation. This is for union. So these are these are called as relational operators. All these are called as relational operators. So in relational operators, you have inner join, you have left outer join, right outer join, full outer join, projection, calculation, aggregation, and union. Now let us see each one of them. What is the importance of each one of these? So what is the inner join? So inner join return records that have matching values in both the tables. So when you have matching values in both the tables, we use inner joins. Now left outer join. So for each one, I'll show you the syntax on how you have to use each one of these when you're creating scripted calculation views. So inner join, what is the C function? The C function for inner join is C underscore join. It is C underscore join. What is the use of C underscore join? The use of C underscore join is it can get matching values in both the tables. Left outer join, the function, this is the function C underscore left underscore outer underscore join. So what is the use of this? It returns all the records from the left table and the matching records from the right table. So basically it returns all records from left table and the matched records with the right table. So in order to get records from the left table and matching records from the right table, you have to use C underscore left underscore outer underscore join. Right outer join. So when you use right outer join, it return all records from right table and matched records from left table. So right outer join, this is the C function, C underscore right underscore outer underscore join. So it returns all the records from the right table and the matched records from the left table. Coming to full outer join. full outer join return all the records when there is a match in either left or right table. So full outer join. So this is the C function, C underscore full underscore outer underscore join, returns all records. When there is a match in either left or right table. So when should you go for projection? Projection is used for selection of columns. So whenever you want to select or rename columns, same like C underscore projection is equal to the projection in the graphical calculation view. So in a graphical calculation view, what you can do with projection? C underscore calculation. Now this is used when you want to create a calculated column. You remember we created a calculated column. So what are calculated columns? Calculated columns are those columns. You can derive a new column based on existing columns. So that is nothing but calculated column. Aggregation. How you would like to summarize a measure. Like you have different aggregation types like sum, mini, max, standard deviation, average, count. All these are aggregation. Union is used to combine results. So these are different operators. So inside SAP HANA there are different operators. And all these are different operators. Now, okay, so this is all related to SQL script. So this is nothing but scripting language. Now, how can you use them based on different scenarios? So projection is nothing but selection of columns. Please see, when we are using the calculation views, we use a projection most of the times. Especially when creating COPA scenarios, we try to use projection. Projection is nothing but you are using for selection of columns. Okay, so next is in SAP calculation engine, SAP HANA, you have C functions for calculation engine. Now, what is the difference between using C functions and the normal SQL statement? What is the difference between using C functions and normal SQL statements? So when you're using normal SQL statements, you replace with C functions. They're especially optimized for SAP HANA. C functions are especially optimized for SAP HANA and always can perform better than the normal SQL statements. So I'll show you an example on how a normal SQL statement looks and how we prefer to create the same statement using C function. Let me show you an example. For example, let us use a select statement. I'll show you detailedly. Each one I'll show you how we have to use. Suppose say your requirement is you want to select columns on a table. So normally how do you write in SQL? In SQL this is how: select customer, comma, product, comma, price, from column table. Select customer, product, price from column table. So this is general SQL statement. Now let us say you want to use the same statement, you want to do it in C function inside the scripted calculation views. C underscore column underscore table, column underscore table, select the required columns. Select customer, product, price, so here this is the column table, C underscore column underscore table. So what is the name of the table and what columns you want to select? So for this syntax, let me show you an example. I'll create one new calculation view. I'll right click on package, click new, click on calculation view. So we are seeing an example on how to select columns using C functions. So I'll take it as C underscore column underscore table. View type is a calculation view and subtype standard, type graphical, use SQL script and click finish. So once you click finish, so in the SQL script, first we need to define the structure. So once you define the structure, we need to write the SQL statement. So for C underscore column underscore table, first we need to select what table we would require. So what is the table that you want to select? So let us write the statement and let us create the output in the output. So here in the output, create columns. First we need to give the output structure here. So let us type KNDNR. KNDNR, ARTNR, VV010. Provide the data type. NVarchar. Provide the length. Customer is 10. Material is 18. VV010 15 and scaling factor is 2. So this is the output we require. And click OK. So let us use the same syntax. So where out. So what is the first thing here we have to give? C underscore column underscore table. Schema name and column table and what columns you require in the output. So where out C underscore column underscore table. What is the name of the schema? Schema is best dot. What is the table you want to require? You want to require these columns. The table name is C1IDA. Give the column technical names. So what columns you require here? KNDNR, ARTNR, VV010. KNDNR, ARTNR, VV010. So it's very simple. In order to read a column table, so this is the C function, C underscore column underscore table, and this is the syntax. Best schema dot table name. What columns you want to read from this? So once you have given these details, click on semantics. Click on semantics. Click validate. And click save and activate. Select the request and click finish. So once you click finish, let us see show log. Click on show log. Activation completed successfully. So let us minimize. So SQL9 is the name of the package. So here C underscore column underscore table. Right click on this scripted calculation view and click data preview. So once you click data preview, click on raw data. So here you can see customers, materials, VV010, which is gross revenue. So by using a scripted calculation view, which is C underscore column underscore table, schema name and the table name. And so this is this scripted and normal SQL. This is how we write in normal SQL. Select customer, product, price from column table. This is normal SQL and this is C functions. So every C functions that you generate, if you click on show log and double click on generated SQL, so copy the statement, so here this is the select statement based on the scripted calculation view. So let us go to underscore sys underscore BIC and let us open this. Let's go to sys underscore BIC. Expand the catalog. Go to the schema underscore sys underscore BIC. Expand. If you go to the procedures, and search for this SQL9. So let us go to SQL9. So here we see here you see SQL9 / C underscore column underscore table. So whenever you create a scripted calculation view, automatically a procedure is generated by system. Double click on the procedure. Please see this is inside the procedure. Begin, where out, end of procedure script. So whenever you create a scripted calculation view, automatically a procedure is generated in the backend. So what is the use of generating a procedure? Whenever you keep data and logic together, it executes faster. Procedures are executed inside the database. So when you keep logic and data together, it executes faster. So the advantage of procedure is it completely executes inside the database along with data. So let me show you a difference for the other C functions. So this is one to read tables, and then you have other ones like, for example, these are all called as data source access operators. All these are called as data source access operator. So how many data source access operators you have? There are 4 data source access operators. So how many relational operators we have? There are 8 relational operators. So what are those 8 relational operators? Starting with join, C underscore join, left outer join, right outer join, full outer join, projection, calculation, aggregation, union. All these are 8 operators. These are called as relational operators. And these are called as data source access operators. First one is C underscore column underscore table. C underscore join underscore view. C underscore overlap underscore view. C underscore calculation underscore view. So these are the 5 data source access operators. Now let me show you for each one of them. I'll show you an example for each one of them. Let us start with C underscore join underscore view. So let us go to the package. Right click on the calculation view, click new. C underscore join underscore view. View type is SQL script. Click finish. Click on SQL script. So first we need to give the statement. So in order for using C underscore join underscore view, first let us try to select what views we require in order to achieve this. So let us take few attribute views. I'll take few analytic views and take few calculation views. So C underscore join underscore view is mainly used for attribute view. C underscore column underscore table is used to read column tables. C underscore projection is used for selection of columns. And C underscore join is used for inner join. So based on these different examples, let us start to create. So first you need to declare a variable. T1 is equal to, give the C function, C underscore join underscore view. C underscore join underscore view. So from where you want to request this. So when do you use this? You use when you want to read attribute view. So where are these attribute views are available? Under sys underscore BIC. So give underscore sys underscore BIC. Now here, what is the attribute view you want to read? So let us give the package name and the attribute view name. So let us find out one attribute view here. Let me find out. Let's go to SAP ECC. One minute, just try to find out. So let us go to, where are my Word packages? Let us take from here. Double click on the customer, click data preview, click raw data, click on show log, double click on generate SQL. So let us copy this statement, package and the view name. Let's copy the package and view name. So from here, what columns you require from this? Same syntax. KUNNR, name 1, so here C underscore join underscore view underscore sys underscore BIC. So this is the package and the attribute view name. So here we are basically taking the column names. So let us define the output. So what is the output we require here? Click on create columns. We require KUNNR, name 1, VV010. We require the customer name and gross revenue, and varchar. Name is 35 and scaling factor is 2. So this is the output I require. Click OK. So here from the customer attribute view, please see from customer attribute view, so this is the customer attribute view. From here you got customer name 1, both of them. So now we would like to get VV010, the third column. So in order to get the third column, I'll go back. Let us define the T2 variable, C underscore column underscore table. What is the schema? Let us drag and drop the table. Let us go to catalog, Go to the best schema. Go to C1 IDA table. Select the table and drag and drop this table inside this. So schema name and the table name. Here what columns you require. What are the different columns that you require over here? KN, DNR, VB010, so please see here, the first statement I'm using is C underscore join underscore view. This is for attribute views. The second thing I'm using here is C underscore column underscore table. Now when I want to join KUNNR with KNDNR, the column names are different over here. If I want, I can rename this column to KUNNR. In order to rename this column to KUNNR, I'll use projection T3 C underscore projection. A variable is T2. What I want to do in T2, I want to replace KNDNR as KUNNR. So from the variable T2, I want to replace KNDNR as KUNNR. So I'm using inside the projection. So at the projection, KNDNR, so in the T3, I'm using C underscore projection. I'm using the variable. I'm trying to rename KNDNR as KUNNR VV010. Same thing I'm trying to rename like this inside the projection. Let's go to where out. So where out, let us do a join. Let's do a join on C underscore join. So on what you want to do a join? You want to do a join on T1 variable. Just I want to show you what is the use of a projection. In order to show you the use of projection, I'm using this. Otherwise, this is not necessary. Just it is to show you the use of projection. So variable T1, T3, KUNNR. So this is the join. So I'm defining the join condition here. So what is C underscore join? What is the use of this? What is the use of C underscore join? C underscore join is basically used for matching values. Nothing but inner join. It's an inner join, C underscore join, for matching values. So we're using C underscore join to get matching values from output of T1 variable, output of T3 variable. The common column is KUNNR, and the output that you have here is KUNNR, comma name1, comma VV010. So it will give common values from both these tables. So finally, let us click on validate and click on save and activate. So let us click on semantics. So this is the output, KUNNR name1 VV010. Click validate and click on save and activate. Select the request and click finish. So in order to see the procedure, let us go back to C underscore column underscore tables. So go to the catalog, go to underscore sys underscore BIC. So you can use a call function. You can use a call function to call procedures. Right click on the procedure, click refresh. So inside the project, inside the procedure, so let's try to find this. Not able to find. 1 minute. Just trying to find this. I think it's not active, that's why you're not able to see. So let us go back and check once again. Oh, sorry, here I did not give the entire output. So I've only taken until the common column, but we need to give the output here. So that's the mistake over here. So we need to give the projection. So what is the projection over here? The projection is KUNNR name 1 VV010. So this is the final output. So here T1 is a variable. So first we're giving the join view. Second we're taking the column table. Third we are using the projection. We're trying to rename the column KNDNR to KUNNR. And the fourth we are defining the output var out C underscore join. So this is the join condition on T1. The common column is KUNNR. When the KUNNR name 1 and VV010. Click on validate and click on save and activate. I did not define the output, so that's why it did not able to generate. So let's click on show log again. So now it is completed successfully. So previously I did not notice this error. So let us go back to the procedure. Right click on the procedure, click refresh. So here is the new procedure SQL9 C underscore join underscore view. Double click on this. So this is the output statement. So you can use this procedures by using the call statement. So how do you call a procedure in SAP HANA? In order to call procedures in SAP HANA, you can use call underscore sys underscore BIC, give the procedure name. So once you give the procedure name, click execute. So we have to use the call procedure statement. So let us see the data preview for this. Click on data preview. Click on raw data. Click on raw data. So here we can see customer, customer name, and customer gross revenue. So in this, what we are trying to see is the syntax for join view, syntax for column table, how to use a projection, and how to use a inner join. Let us see next example. So here there are data source access operators. So in data source access operators, We use C underscore column underscore table. We use C underscore join underscore view. Then what is the use of C underscore OLAP underscore view? C underscore OLAP underscore view is used to read analytic views. C underscore calculation underscore views are used to read calculation views. So same like an attribute view, syntax is same, everything is same. But the only difference here is you're using an attribute view, you can use an analytic view, or you can use a calculation view. But for everything, we use the same syntax. So like this, I've got a lot of examples that we created. I'll show you where you can find these examples. Go to a package called HBA. Go to a package called HBA. So the HBA package, it's HDB. Once you go to the HDB package, expand the HDB package, expand the HDB, expand SQL, expand calculation views. So for everything, there is one example over here. Like C underscore join underscore view. So this is the same example. Now when you want to use C underscore OLAP underscore view, double click, click on scripted views. So this is one example for C underscore. So you're reading an OLAP statement, you're reading an analytic view. And here is the output. So I can change this. I'll take any analytic view. So let us take this analytic view. Click show log. Let us take this analytic view. So let us copy this. Copy the column view name. Just you can change the code. Instead of recreating everything again, just we can change the statement. Your package and the analytic view name. Columns are same. KNDNR, ARTNR, VV010, VV070. Click on edit columns. So here you have these columns in the output. Click OK. Click validate and click save and activate. Let us select the request and click finish. So like this you can change for all the statements. So just what you have to do is just try to copy to your own package. Copy everything to your own package. So go to HDB package, HDB. Go to HDB. Right click on this. Right click on all these objects. Now when you want to copy all the objects from one package to another package, we can use something called mass copy. So where do you find mass copy? Click on window, click on perspective, reset perspective, click yes. Click on mass copy, select system, click next. So what is the source, what is the target? So I would like to copy from SQL1. Yes, you can create a copy, mass copy, and you can practice these own examples. HDB, copy to SQL9. From this package to this package, click next. Once you hit next, what you want to copy? So under this you have HDB. I want to copy SQL1. All these calculation views. Click add. Also you want to copy the procedure. Click next. So now we are copying this. So these are all the different source objects. This is the source package. And this is the target package. And finally click finish. So once you click finish, it started to copy the data model. Copied, completed successfully. So if you go back to SQL9, expand SQL1, expand calculation views, so here you have these different calculation views. So suppose say you want to use any of this, let's say C underscore union underscore all. So how do you use C underscore union underscore all? Click on skip view. So C underscore column underscore table. So let's use, instead of this, let us change to best. C underscore column underscore table. Let us use the best schema. C underscore projection T2. So here we are trying to rename measures. Please see VV010001. We're trying to rename to VV010. Where out C underscore union underscore all. So this is to combine data. T1 and T3. You want to combine T1 and T3. So here is the edit column. So this is the output. So this is the output that we require. Click OK. Click on semantics. Click validate. And click save and activate. Select the request and click finish. So C underscore union underscore all is activated. Let us see the job log. Job log completed successfully. Click on data preview. Click on data preview. Now we are trying to combine data from, so here in the union we're using C1 and CE2. We're using union underscore all. Click raw data. We're trying to combine both C1 and C2 tables, and this is the output. So like this you can change whatever the code that you require. Now let's come to left outer join. Double click on the left outer join. Click on script view. So here we are using an analytic view. We are using a calculation view. We are using projection. And where out we are using C underscore left underscore out underscore join. Coming to C underscore right underscore out underscore join. Same thing, same procedure, but the only difference here is we are using C underscore right underscore outer underscore join. So this is right outer, this is left outer, this is C underscore union, this is C underscore overlap, this is for join, this is for analytic view. So if you want to know which one of them are relational operators, and data access operators. So this is a data access, this is relational operator, this is a relational operator, this is data access operator. Join is data access operator, column table data access operator, data access operators. Aggregation relational operator, vertical union, trace. So this is used for trace. Where out, not to trace, so this is C underscore column table. C underscore calculated column, C underscore where out C underscore projection, KNDNR, ARTNR, VV01070. Here we are creating a new calculated column, VV010 minus VV070. So you can practice this. I also given the assignments. So I created about 10 assignments. In order to practice on SQL script. So any questions until here? So here we have one question here. The question is, what is the use of vertical union and what is the use of trace? Okay, so vertical union, now this is the function. It is used to concatenate columns from more than one source. If you open the vertical union, please here I'm trying to concatenate. This is basically used to concatenate columns from more than one source. So in this scenario, the number of columns that are all needed would not be same. Like when you are using C underscore union underscore all. So in this example, you take C column table, you're reading a column table, and then you're taking C1 IDA. When using vertical union, variable T1, KUNR as customer number, name as name, T2 as ARTNR, and VV010. So basically, there is no direct functionality for C underscore vertical union inside the SQL. We don't have this functionality as a direct function inside the SQL. Then C underscore trace. So C underscore trace is used for debugging when you have calculation use C functions inside SAP HANA. The input can be one of the C function. So you can take any input in the C function. This will capture the output and we can validate after it executes the calculation view. So what you see in the output, the difference. So basically you can see a different C functions available in SAP HANA. So let me once again just recap everything until what we have seen until here. Just I try to recap. First of all, calculation engine plan operators. What is the use of it? It does data transformation functionality. It can be used in the definition of functions. They consider it is basically used as the logic directly implemented inside the calculation engine. What is that? You can directly implement this inside the calculation engine. So in here there are two different categories. So what are the two different categories? The first category is data source access operators. What is the use of data source access operators? They bind a column table or a column view to a table variable. So basically you're binding everything to a table variable. Whereas relational operators allow the user to bypass SQL processor and directly interact with the SQL engine. Data source access operators bind column table or a column view to a table variable, whereas relational operators allow you to bypass the SQL processor and directly execute inside the SQL engine. Directly execute inside the calculation engine. So what are the different data source access operators? You have C underscore column underscore table that provide access to an existing column table. Then you have C underscore join underscore view. Now this operator returns results from an existing join view, or also known as attribute views. Then you have C underscore OLAP underscore view. C underscore OLAP underscore view operator returns results from an existing OLAP view, which is known as an analytic view. Then you have C underscore calculation underscore view. Now this operator returns results from an existing calculation view. Then you have relational operators. So what are the different relational operators you have? You have C underscore join, which is nothing but an inner join. So for each pair of join attributes, only one attribute will be in the result. So basically it's an inner join. Then you have left outer join. It calculates the left outer join. Right outer join, it calculates right outer join. Full outer join. C projection, what is the use of C projection? Restricts the number of columns or the selection of columns that you want to do. Then you have C underscore calculation. C underscore calculation is used inside the operator when you want to create an expression or you want to bind to a new column. You want to create a new columns. Next is C underscore aggregation. Aggregation is used to group. It basically computes the aggregation for each group. Like you can use count. You see, here I use one example here. Double click on C underscore aggregation. Click on script view. So here you are using count. So how you would like to summarize a measure. Then C underscore union underscore all. C underscore union underscore all function. It is to compute the union of two tables. Then you have vertical join. Vertical join applies when you want to concatenate on the other columns or you want to rename. And then the last one is C underscore trace. A trace operator is used to debug SQL script procedures. So these are different C operators inside SQL script. So normally SQL and SQL script are two different things, but the main advantage of this is it executes when you're using relational operators. It bypasses the SQL processor. It bypasses SQL processor and directly executes inside the calculation engine. In the interview, they will ask this question. Relation operators allow you to bypass SQL processor and they allow you to directly interact with the calculation engine. What is the use of data source access operators? Data source access operators bind a column table or a column view to a table operator, to a table. So basically you bind to one table variable. So let us see what is the use of decision table. So when you right click on the package, click new. So here you have something called decision table. What is the use of decision table? Decision tables are mainly used for writing business logic. So in SAP HANA, decision tables are created as procedures. I'll give you an example. Let's say for a customer who is returning, you want to give the sales discount 10%. For a new customer, you don't want to give any discount. So you can write these different conditions inside the decision table. Inside the decision table, we can write different conditions. Like, especially when we go to a supermarket, we have something called point system. Every time we need to, they add point to the cards. Now, when you have points more than 2 lakhs, you're a gold customer. When you have points less than equal to 2 lakhs, then you are a silver customer. So these kind of rules can be written inside the decision table. So dt underscore sales, click finish. So here is the data foundation. Click on the data foundation. Click on the plus icon. Let us add one table, VBAK, from best schema, and click OK. Let us try to select 2 columns. Click find, or let us select VBLN, and then you can find NETWR. So you can write business rules without doing or knowing any programming language. So right click on the variables, right click on VBLN, add as a condition, right click on NETWR, add as an action. Right click on the calculated columns, click new calculated column. I would give NETWR, so the output will be written into this column. Data type is decimal, length is 15, scale is 3. Expand attributes. So let's click add. So I'll take this calculate attribute as my action. One minute. It's not allowing. So what I'm trying to achieve here is, what am I trying to achieve here is, so based on each sales document, it has to calculate, and results should be available in the new column. So here we need to take VBLN as a condition and NETWR as an action. Click on decision table. So here you have the default value. Click on show list of values. Select the sale order. So here you can write NETWR into 10 divided by 100. Let us right click, add condition value. Let us take the sale order. Click OK. So if you want, you can change this 20 divided by 100. Click on validate and click on save and activate. So once you right click, validate the decision table, model validated and activated. So for the same decision table, expand the catalog underscore sys underscore BIC. Right click on procedures, click refresh. Go to the SQL 9 package. So here we created SQL 9 DT underscore sales. So this is a decision table. Double click on this. So once you double click on this, so this is the procedure system created. So without knowing any programming language, so without knowing you can develop business rules with no programming language and use these results to analyze or to do comparisons with actual data with the help of decision tables. Decision tables are used mainly for business results. They're mainly used for business results. So you can use these decision tables directly. You can use them inside the business objects business intelligence suite to create a universe. So directly we can use them inside the business objects business intelligence suite. So I'll stop today's session. So in tomorrow's session, what we'll do is we'll see the concepts of CDS views, code data services views. I'll show you some scenarios based on S4HANA. We'll see scenarios based on S4HANA in tomorrow's session. Core data services from ABAP, how to expose core data services to ABAP S4HANA. And towards the end, I will show you resumes, the scenarios that we developed, and errors. So frequently occurring errors in SAP HANA project. So you have 10 scenarios and about 30 errors are there. Tomorrow we can discuss them. So SQL script. So we are using SQL script. Everything can be done in graphical mode. But you also have an option to do it in the scripted language. So both options you have. You can go for a graphical mode or you can use a scripted view. But the results are same. There is no difference in the results. So tomorrow we can see CDS views, AMDP. All this I will show you in tomorrow's session. Thank you everyone. Have a good morning and good night. Thank you.